What I'm going to do now is talk about using Git for OpenVSP model version control. And Git is a version control and file control system that allows you to branch apart and make changes to your models without actually affecting the source itself. So for a bit of a discussion here, we're going to go over why we would use Git, a little bit of the nomenclature associated with Git processes, and some different flavors that we have of Git and how you can use those. And at the end, with time permitting, we're going to go ahead and do a demonstration using GitHub Desktop and show how you can make some changes and do some version modeling in real time. So in this case, we're talking about version control for models rather than for software source code. So this can include things like your VSP geometry, various performance models for different software, your design inputs, notes, scripts, etc. All of that can be version controlled in the same directory. And this can apply to a single designer or multiple designers working on a model. So each individual can modify the model as they need at the same time and then merge those changes together when it's complete. So this enables extensive collaboration of very complex OpenVSP models or libraries. And this avoids the tendency to save multiple copies of the same model as the design progresses, to where you go, oh, well, I want a backup of this. So I save the new one after I've made some changes as some elaborate file name, and eventually you have no idea how you got there or where you made a change. This alleviates all of that, so you don't have multiple copies of the same thing cluttering up your workspace. So why use Git in particular? It's because it's a simple, clean, and easy to use version control of a variety of file types. And you can save the files as much as you want without affecting the stored version in your file structure. So if you make a change to a VSP model, for example, and you save that, you can always reset all of those changes back to before you did what's called a commit. So you can modify as much as you like without fear of losing your work at any point in the model chain. This is also a highly collaborative environment for user-controlled resources. And you can work locally on your laptop or online at, say, GitHub or GitLab, and the changes that you're making are tracked on both. And when you're checking out a copy of a repository online, you're not only working with the piece that you're dealing with, you're working with the entire history of the project. You can see every change that was ever made, and this is called Distributed Version Control System, or DVCS. So there are multiple backups of the project in case something is corrupted or lost, say on your machine or on a server. There's always something somewhere that has the entire project history. And of course, the OpenVSP source code is on GitHub, and it's at that link right there. So the nice thing is that VSP models are essentially an XML-based code. It's all human-readable format. And in fact, few VSP files are unformatted in a way where you couldn't just go in and read what it is if you understand the syntax and the language. Now, you can version control everything in the repository, including things like VSP scripts, Python code or scripts, MATLAB codes, design files, variable files, configuration setups, analysis input and output files. And you can also put things in there that are unformatted or binary files like PDFs, images, Excel, etc. The thing is that the unformatted or binary files are tracked, but you don't necessarily see the differences because it's not human readable. It can't do a diff operation between those two and tell you exactly what changes. It just knows that it did. But there's nothing at all wrong with keeping those files inside the repository so that everything's in the right place. And the documentation uses the markdown language, which is very useful for keeping a summary or a description README file, so you can always see what's going on and what the model is about. So, a bit of nomenclature when we're just talking about things with Git. Branches are basically parallel versions of the project where you can safely make changes and experiment and fix bugs, doing things like that, without having any effect on the master copy of the project. So it's just, I've checked out a version of this to work on. A fork is a term that implies making an online copy of the main repository. So instead of it belonging to the collective group, you've taken that and you've split it off and made it a completely different copy. It's not checking out, it's a different operation. When you clone something, it's making a copy of the online repository to your local storage. So you're going to clone that online repository and it's going to build everything right there on your machine. And when you check out, that's working with a specific branch, or you can create a new branch when you check out. And one of the really important ones is this term called commit. And a commit is when you say that you want to add all of the changes that you've made up to this point into the project history. You're happy with it, it's stable, it's exactly the way you want, and so you commit those changes to the project. And with a push or a pull, it's either pushing changes from a local copy to an online repository that you have stored, or you can request that people pull the changes that you've made into, say, the master branch. So a few different flavors of Git that are available are, Git-bash, and this is a Linux-style command structure. It's essentially a terminal that lets you operate in Git and manipulate the repository in a command line structure. And typically this is quite a bit quicker than using a graphical user interface or a GUI. So in this example, you can see over here that we've got the master branch, and we make some changes and we make a commit, and this entire string here is the commit hash ID, or the SHA. So it gives an identification key to each change that you make so that you can track it, see what happened. It says who did it and when it happened, as well as a description and some details. So you can do all of this in Git-bash, and there's actually a handy little cheat sheet for Git-bash located here. So some useful commands in Git-bash are all listed here. This stuff has more to do with initiating a repository or cloning a repository. Most of this stuff down here is how to interact with the repository. So to branch or to check out, to pull or push. And if you do log, that just shows the commit history and it tells you what happened and when. You do git commit with a descriptive message, and that's going to actually execute the commit. And we're going to go through how to use this stuff here in just a second. So an example workflow in Git-bash would be to go to your project directory and initiate, say, my project repository. Then you can add stuff in there. And if you do a git status, what it's going to say is, here are some modified files that I haven't committed yet. These haven't been staged, but they have changed. When you add the file names, it will stage these and be ready for a commit. So they turn green and they say, I'm ready to go. I know what I am. I know what changes have made. So you can add them one at a time, or you can add multiple files at once. You can do an add star.vsp3 or a VSP arrow file, or you can just do git add dot, and that adds everything at once. And then git status again shows that these are good to go. Following that, you can do a git commit m and then type your message, which is just what it's called and then a short description. Or if you just type git commit, it's going to bring up a Vim editor where you can type things like the first line is the summary, and then all of the details can be added in the Vim editor in a human readable and easily seen format. So you can provide some detailed description, you can make an enumerated list of what happened and when, visual separators, etc. Now, because this is a Linux style, remember that to save is just a colon write quit or WQ, and all of that stuff works out. So it's really good practice to add details into each of your commits so you really understand what happened, because nothing's worse than going back 6 months later and having no idea what change you made or why something happened. You're completely lost. So be detailed in your comments. The online version control and collaboration happens mostly on GitHub and GitLab, and similar to other systems, there's a multitude of helpful online tutorials present and available. And you can find those examples online. And there are step-by-step instructions on navigating and how to do operations in Git-bash and work with GitHub, etc. But a lot of the operations in GitHub and GitLab are point-and-click steps. But what's nice is it's helpful in examining the status of the project. They have visualizations on who has what checked out and where it is, how many different branches there are, what version it is, and it has handy visualization so you can see your current project status. It's a really great tool. So in GitHub, you can add saved files and drop them in. You can perform commits by adding a summary message here and then some extra details. And you can either commit directly or create a new branch and then a pull request. So that has to do with making sure someone else can second check what it is that you've done before it actually gets merged into your master code. So GitHub actually offers an enterprise service to where you can do things like SBU and ITAR codes. That is a paid service. So if you happen to be out in industry and you want to be able to use it for that, GitHub does offer that. And I think GitLab may as well. GitLab is very similar to GitHub. It's got the same type of GUI interface where you can drag and drop, type things in, and do commits. GitHub Desktop is a nice little mix between a GUI and all the controls that are available in Git-bash. So it'll give you a quick navigation of a repository. It gives you automatic visualization of the differences in your various version files, and it's found here at desktopgithub.com. So for an example, let's say that we're working in a repository and we have an aircraft, and it will tell you that you have a changed file here. And over here on the right side, it will tell you exactly what changed, including, say, you changed the name of a component, you changed some camera angles, various things. So it also tells you what branch you're working in. So all of that stuff is included in this window. You simply type your commit summary and all of your details and click commit to master. And the next thing that comes up is your history. And it tells you what changed. It tells you your 7-digit hash ID, which is actually just a partial of the full commit SHA. And you get your entire history log here on the left. So all of your details are here. And again, you can go back and see exactly what changed. So in this demonstration that I'm about to do, we're going to open up an example repository. We're going to open a VSP model. We're going to manipulate it a little bit and then save it. And we're going to view those changes, and we're going to stage a commit and then look at the view history. So I'm going to walk you through the process for how to use GitHub Desktop and use a model in a repository. So for that, I'm going to go ahead and escape out of this, and I'm going to bring up GitHub Desktop. So in this case, we're working in my Git demo, and I have no changed files. And this repository is here. So I'm going to open my test aircraft VSP file. Okay, so here I can make this view a little bit bigger and we can see what this looks like. I just quickly press F to center everything in the screen and fit, and we can see this model. So let's say, for example, we want to go into the wing, and maybe this is too low of an aspect ratio. We want to widen this out just a little bit and maybe give it some more sweep. Why not? It doesn't really matter for the demonstration here. So let's give it maybe a little bit more span and maybe a little bit less root chord. And that's not too bad. Sure, why not? And while we're at it, let's give it just a little bit of dihedral. Okay, so we've made a couple of changes, and let's say that we're happy with those. We can go to File and Save. And now, if we come back, notice how it automatically picks up on the file that's changed. It knows that I changed my view center, but if I start coming down this way, it knows that I changed a little bit of paneling. I changed the area, aspect ratio, the chord, some dihedral. There's a bunch of stuff in here, and it's tracking it. Anything in green is what it's set to now. So you can visualize everything that happened in this model. So now we can just say that the summary is to modify the main wing, and the description perhaps is that we added dihedral, we shortened the root, and increased span. Okay? So I could enumerate this. I could make it perhaps a little bit cleaner, a little bit nicer, but for the purpose of the demonstration, you can see what we're doing. All we have to do now is commit to master. If you want to make sure that you're not adjusting the master branch and you want to do something different, you can always make a new branch, then make the changes, which is really the better practice. And then once you're satisfied with all those changes, you merge it back in. So this way you can manipulate things in the model and even make changes to the repository without affecting the master branch. And then when you're happy with the history, you merge it in. But for this demonstration, we're just going to go ahead and commit directly back to the master. You can see that everything is up to date, no local changes. It's offering me to publish onto GitHub if I want. But here in the history, you can see all of the changes back to when I first created this over a year ago. And each one of these has the history. And each one of these I can reset to this stage in the model development. So you can see that it's got my summary here and all of the details included. It's got my hash, it tells me what happened, etc. But I can go back and look at this at any time. And no matter how much I go in and change the model and save and manipulate things, if I'm not happy with those changes, I can simply reset. I can clear all those changes out and come right back to this point. So you can see how useful it is to be able to control your OpenVSP models in this way so that you don't have a bunch of backups of backups of backups. And if you happen to have a model development process to where you need to understand the heritage of how you got where you are, this history can be written out in a human-readable text format where it tells you what happened and when, and it gives you the entire history. So you can write this out as a document and append that onto, say, a presentation or with a report that says, here's my model, and this is every single thing that I ever did to get it to this point. So it makes it traceable. And a lot of control teams, a lot of design environments, that's incredibly important. So Git becomes a very useful and very powerful tool in maintaining traceability and version control of all your models. So we're a little bit past, quarter past the hour. I've given this demonstration here. I know that we kind of rolled in from Rob's talk into this one, so I think I'm going to take some time here to answer a few questions if I can, and then what we might do is break somewhere near about 20 past the hour, and we'll start up again around 1:30. But for the time being, let me go ahead and just answer any questions that might be out there.
Thanks a lot, Brandon. I don't see any questions. Let's see, one just came up here. Oh, just thanks for the GitHub tricks on using the model. If anybody else has questions about using version control with VSP models, now's a great time to ask them, or anything else that you might have about what Brandon said so far today. While we're at it, in general, those of you who didn't join us at the very beginning, to get the highest quality stream, you need to tell YouTube to use the HD option. There's a little gear in the bottom right corner of your YouTube stream, and by default, it might be on low D. And if it's on low D, you're not going to be able to see the screen very sharply when Brandon does a live demo. So be sure to switch it to HD if you haven't done that already.
All right, let's see. No, so far I'm not seeing any extra pop-ups. For everybody out there following along on the YouTube Live, I did post a link to the NASA OpenVSP Workshop Social Q&A if you prefer to use that, where it can have almost like a sticky post that we can upvote and see, because depending on how busy the YouTube live chat happens to be, it might get lost in the queue there. So if you have something that you really like to be answered eventually, go ahead and pop that over, because the NASA social Q&A is the one that we're going to be writing out the report at the end of the day and saving. I'm going to try and make sure that some of the chat from the VSP Live is saved as well. It should be, but I'm not certain. So we're going to be trying to keep track of all these questions and answers so that you guys get this stuff in real time, and we can save it so you guys can go back and reference it later. It says, we've got a question here in the YouTube Live. It says, about the hinge component, can the hinge translation or rotation change during an evaluation, like you can set for range in an angle of attack or mock? So I wonder if they're asking if that can change in between or iterate in something like maybe VSP Arrow, perhaps?
I think that is the question. So I would say that VSP Arrow doesn't know about your hinge and about your model. So although VSP Arrow can easily sweep alpha, beta, and mock, it doesn't have the ability to say sweep an F-14's sweep angle on the wing or V-22's tilt angle on the nacelle. But that said, you can certainly change it yourself manually and run a hover case of a V-22 and then run a cruise case later. And you could also certainly use the scripting that we'll be talking about on day 3, either through VSP script, which is built in, Python or MATLAB using the API, to run a VSP arrow analysis, then change that hinge angle, then run another analysis, then change the hinge angle. So you can certainly do that. Also later today, one of the talks I'll be doing, the design variables, I'll also be talking about variable presets. Variable presets are useful because when you have an articulated model, because you can set up different configurations of your model. For example, in a model that had both flaps and landing gear, you could have separate configurations for taxi, takeoff, landing, and cruise, where those all have the appropriate settings for gear up, gear down, and flaps in either the stowed, takeoff, or landing positions. So you can, and we'll talk about that during the design variables and presets session later today.